All right, so yesterday we talked about percentiles, which I told you were one of the measures of position where you could tell how one thing compared to others. Today we're going to expand that and talk about one other fairly important measure of position, which is what are called quartiles. I mentioned that there were two or three other things we could theoretically talk about, but we're going to stick with the two biggest ones, which are percentiles and quartiles. Quartiles literally come from the word quarter, because what you're doing is finding three numbers that divide your data up into quarters, into equal parts. It's like if I listed everything off in order, I'd go around until I'm a fourth of the way through the data, then I go along until I'm halfway through the data, then I go to 3/4, and finally you go to the very end. And it does turn out, we call those Q1, Q2, and Q3 usually. You might have actually seen on your calculator Q1 and Q3 when you were finding some of the statistics before, and we'll talk more about that in a minute. It turns out that Q2 is exactly the same thing as the median. It's literally the median of your data. Q1 is just the median of the bottom half. It's like I just limit myself to the first half of it and I find where's the middle of that. Because if you think about it for a second, halfway between the start and the halfway point must be a fourth of the way. And that is exactly what we're doing there. And similarly, Q3 is just the median of the top half. Now, while I'm going to literally do that by hand in a second, generally what you're going to do is let your calculator do it for you, and it's no big deal to do that. So just median, median of the bottom half, median of the top half, that's all we got for quartiles. So if I had numbers like 1, 2, 2, 3, 4, and 5, would you agree the median of that is 2.5? Halfway between 2 and 3, and that's exactly right. Well, then if I just limit myself to the bottom half, 1, 2, 2, the median for those three numbers is going to be the first of the twos. And then if I look at the top half, 3, 4, 5, I'm pretty sure the median of that is 4. And so my quartiles are going to be 2, 2.5, and 4. Those would be the numbers that we have. Now, if you got your graphing calculator, I'd like you to take a second, and we're going to literally do this problem with your graphing calculator as well. Because all I want you to do is just go to Stat Edit and put the 6 numbers I have at the top there in list 1. So 1, 2, 2, 3, 4, 5, clear out whatever else is there. Get people getting others there as well, but again, it's just Stat, Edit, and then put those numbers in your list. And after you're done with that, what you want to do is calculate one variable statistics, so stat, calc, and pretty much just keep hitting enter. And you should remember that before you could like hit your down arrow to find the median. That's pretty much what you want to do. Because once you get those numbers in there, you should get a result screen that looks something like what I have at the bottom there, where it does tell me that the minimum number was 1, the lower quartile is 2, the median's 3.5, the upper quartile is 4, and the maximum is 5, I believe, according to what I had there. And yeah, those, I believe, are those numbers. Okay. Everybody see how we're finding that with those? Okay, so we're going to just expand that slightly, mostly showing you a little bit of vocabulary you'll see with things in the book, and also talking about a way that we can show that graphically. We're going to talk about what's called the 5-number summary, which is literally what you just saw on your calculator. That is called the 5-number summary, and what it does is it's just a quick way of sort of showing where your data is. It traces it along from the bottom all the way to the top. And looking at those 5 numbers, you can get a little bit of an idea of how spread out this is, where things are located, where's the middle. All of that stuff shows up fairly quickly when you just look at those 5 pieces of data. There will be a few problems where you're asked to find the 5-number summary, and all it's asking you to do is that. That makes sense to everybody. You can also show that in a graphical way using what we call a box and whisker plot, which doesn't have to look like a cat, but can. What a box and whisker plot does is it shows you those 5 numbers along a number line. And what you do is you make like a box that has a line in the middle of it that's in the middle of this, and then little whiskers that extend out to the sides. What the box is doing is focusing in on the middle of your data. The line in the middle of that box is the median, and the sides of the box are the lower quartile and the upper quartile. So I can basically say, like in the graph you're looking at there, half of our data is between, probably about 51 and 86. Just looking at where the sides of the box are. And I can say a fourth of the data is between about 18 and 51. And the top fourth of the data is between about 86 and 100. Do you see where I'm getting that from looking at what we have there? So the minimum and the maximum are the ends of the whiskers. The sides of the box are the quartiles, and the middle of the box is the median. And here it is just saying that in a slightly different way. And here's another picture that's basically showing you the exact same thing. So if I looked at the picture that's on the left here, can anyone tell me what would be the median of this data? Yeah, Amanda. Okay. And I don't know if it's exactly that, but it certainly is very close to that. And if I asked a question like that, anything that's in the neighborhood is going to be a correct answer. So what if I said, let's try this. What's the range of this data? So I heard 20. And I think what we're saying is it goes from somewhere around 62 to 82 is more or less what people are saying to come up with 20. And if you subtract those, you do get about 20. It might be slightly more like 21, 22, something like that, depending on exactly how far things spread out. But yeah, that's exactly the right idea on it. There's one more term that sometimes will be asked, which is the interquartile range. And if you think about what that word says, it literally tells you what you have to do. The interquartile range just means how far is it between the quartiles. So like if I look at the picture on the left, looks like the lower quartile is somewhere in the upper 60s. I'm going to say maybe 68. Looks like the upper quartile maybe is about 77. And so if I did the interquartile range, I'm betting it's probably about 9, just subtracting those two numbers. You see what I'm doing to come up with that? You could do the same sort of question on the one about diastolic blood pressure over on the right. I can look at that and figure out, gee, looks like the median is a little bit over 70. I can find out that like the upper quartile appears to be maybe 77 or so, somewhere above 75. You can look at the same numbers, it's just reading on a vertical graph instead of horizontal. And I've got a couple of other things we'll look at. Here's one where they're looking at the weights of NBA players. Normally, you won't see things pointing out exactly where everything is, but you do have ideas on there. Now, you'll notice on this picture, there's an arrow that's pointing to upper quartile. If somebody asked me on this problem, what is the upper quartile? I would probably give an answer like 230. There's another usage for that, which basically means all the numbers from 230 to 300, whatever. That means everything that's in that top part can also sometimes be called the upper quartile. But if I ask that, I'm typically looking for one number, okay? And this last one, I'm going to refer back and forth to this picture because I have a couple of questions that we're going to look at. So this is actually showing various farms, and it says the farms in which place have the highest median. So you may or may not be able to read the words off at the side. But remember, median, what I'm looking at is the middle of the box. So thinking about that, does it make sense that the graph that's next to the bottom, the next to last one, would have the highest median, which happens to be Waseca? These are places in Minnesota that you're looking at here, but that is what we have. So how about the smallest interquartile range? And let me go back to the ones we actually wanted to look at, which is here. Well, it looks like it might have the smallest interquartile range. You can either give me a place or you can like locate it on where it is on the set of graphs. Yeah. The very top one, yeah, which is Duluth. And it is going to be the narrowest box is what I'm really looking for on that. And we'll look at just a couple of others. What has the lowest overall yield? Well, if I look for the lowest overall yield, where am I looking at? Yeah, the very left side, basically, like the left side of the whisker, and it's the second one, which would be Grand Rapids. It's going to have the lowest overall yield. Everybody follow how we're interpreting those types of graphs. Okay, so today you're going to do a little bit more practice with percentiles, and then you're going to find some quartiles, and you're going to look at some box and whisker plots and interpret it. That is where we're at, and hopefully things will work out well with those.